So when we have a first order linear differential equation of this form, where we have dy by dx plus y multiplied by some function of x equals another function of x, there's an established method to solve this using something called the integration factor. And if we look at the question we have here, it almost looks like it follows that form or that template, because we do have a dy by dx, we do have a y, and we have a third term. So if we're going to try to apply the integration factor method, the first thing we need to do is to make our question look like the template in blue. And the first thing you want to do is make sure you only have two terms to the left of the equal sign. So you want the dy by dx, and you want the y times a function of x. So the other term that contains only x, we don't want that on the left. So we're going to want to add that to both sides or to move that to the other side. So that becomes our p of x. So I can write that now as the first two terms unchanged, but then I move the negative term to the right and it becomes a positive, and I've done away with the brackets. Okay, so it looks like that's going to be my p of x. But now I want dy by dx not multiplied by anything. But here I have this term 2 over 2x plus 3. So what I can do is multiply the whole equation by the reciprocal of that. So I can multiply the whole equation by 2x plus 3 over 2 in the hope that that will then make my question look, in form at least, similar to the template in blue. Okay, so when I multiply the first set of brackets, I need to multiply by both terms. So when I multiply 2x plus 3 over 2 times its reciprocal, I end up with 1. So that will give me simply 2 over 2x. Sorry, it'll give me simply dy over dx, because the 2 will cancel with the 2, and the 2x plus 3 will cancel with the 2x plus 3. And then when you multiply 2x plus 3 over 2 times y, you end up with, let's just write it in full, 2x plus 3 over 2 times y. So that's the left-hand side of the equal sign. Now, the right-hand side, it looks like this 2, I can cancel with that 2, and I end up with a product. So let's just write it as 2x plus 3 multiplied by e to the minus 0.5 x squared minus 1.5x. And I'm going to let's stick with that. Okay, so now I think it looks like it's in the form of the form written in blue above. So let me just copy it from above. This is the standard form. So here we have dy by dx, and that matches that. And we have y multiplied by a function of x. And it looks like that function of x is going to be 2x plus 3 over 2. So that looks like it's my f of x. And on the right, we have this big function of x. And that looks like it's going to be my p of x. So that's reassured me that the question actually can be solved using the integration factor method because it matches the form or the template that we have. So for the integration factor, remember the integration factor is it's e to the power, the integral of f of x dx. So that's this box there. So I can simply substitute that and say the integration factor is equal e to the power exponential of 2x plus 3 over 2 dx. Now, let's simplify that fraction. It looks a little awkward, so we can write that as 2x over 2 plus 3 over 2. And that's easier to differentiate. And I can cancel the 2's. So my integration factor is now e to the power integral of x plus 3 over 2 dx. Now, the integral of x is simply x squared over 2, so you add 1 to the power, and then divide by the new power, and 3 over 2 integrates to 3 over 2x. So this is now my integration factor. Let's put that in a box. That's really important. We're going to use the integration factor in a minute. So once we have the integration factor, the general form says that the integration factor times y of x that we're trying to find is equal to the integration of the integration factor multiplied by p of x dx, where p of x, remember, is that expression in the yellow box to the right of the equal sign. So now we can substitute what we found for the integration factor here and here, and we can substitute what we found up there for p of x. So I'm going to bring that down here. And what we're trying to find is y of x. So let's write it out in full. So the integration factor is e to the x squared over 2 plus 3 over 2x multiplied by y of x. That's what I'm trying to find. That's equal to the integration of the integration factor again. So I'm just going to copy it from here. Multiplied by p of x. Now, p of x is this big expression here. So I'm going to write that here, 2x plus 3 times e. Now, what I'm going to do is instead of writing negative 0.5, I'm going to write negative x squared over 2. And instead of minus 1.5, I'm going to write minus 3 over 2, because it's the same. And you can probably tell why I'm doing that. So now that's my expression. It looks like everything has become more complicated rather than less. But remember, what I'm looking for is y of x. And the idea of the integration factor here was to make my integration easier. Now, it doesn't look like it's made anything easier. But if you look carefully, you have a product of two exponentials. So here I have an exponential multiplied by another exponential. And remember, in general, when you've got a to the power m multiplied by a to the power n, the result is a to the power m plus n. So when you have e to the power something times e to the power something else, what you do is you add the powers. And if you add those powers, it looks like you end up with nothing. You end up with 0, because x squared plus 2 minus x squared plus 2 is 0. And 3 over 2x minus 3 over 2x is 0. So you end up with e to the power 0, which is simply 1, multiplied by 2x plus 3 dx. And that's a much easier integration. So the integration factor has actually helped. So let me rewrite the left. Now, on the left, we don't need to integrate. So we just need to integrate the bit on the right. Now, remember, e to the power 0 is simply 1. So what you're actually integrating is just 2x plus 3. So here we have 2x squared divided by the new power plus 3x plus a constant. So that is the answer for the integration. That's not y of x, but that's the answer for the integration. To find y of x, you still need to divide by this integration factor term. So we still need to get rid of this. And to do that, just divide both sides by that. So I can simply say y of x equals the right-hand side, where obviously these two cancel. So you've got x squared plus 3x plus c divided by e to the x squared over 2 plus 3 over 2x. And that would be your final answer. You could leave it like that. Now, if, like me, you don't like fractions, you could bring this denominator up to the numerator, but then you would need to multiply the power by -1. So remember, 1 over a to the power n is a to the power -n. Okay, so it means I would need to rewrite that. Instead of being a fraction, it would be a product. So my final answer I can write as y of x equals, and I'll start with the exponential. So it's e to the power x squared over 2 negative 3 over 2x. So that's my denominator that I've brought up to the numerator. And then instead of division, now we have multiplication. X squared plus 3x plus our constant. Now we don't know what the constant is, so this isn't our final solution, but it's our what we call the general solution. And for this question, it is the final solution. So in terms of what we've been asked to find, which is to solve the first order differential equation, we have now solved it. We have found the general solution. That's why in terms of x, even though we have an unknown constant c, so this here is our general solution. So I hope you found that helpful.